Lesson 66, signs of fractions and 30, 60, 90 triangles. All right, the first thing we're going to talk about very briefly is signs of fractions. We're going to work on just changing, using a rule that a negative times a negative equals a positive, to change denominators in fractions, and then combining like terms to add fractions. So very quickly, if I have the fraction 1 over x minus 3 minus 7a over negative x plus 3. Now we know when we have fractions that we have to have a common denominator in order to add them. Notice that we have the same variable and the same numeral in our denominators, but one is negative and one is positive. So what I can do is I can take my negative here and multiply it times my negative here. That will change the sign of every term. So that changes this to positive, it changes my x to positive, and it changes this x here to negative. So if I do a negative times a negative, I will end up with a positive. So it'll be 1 plus 7a. This one is over x minus 3. And if I multiply negative x plus 3 times the negative, it will be x minus 3. So now I have like denominators, and I can combine like terms. So my solution is going to be 1 plus 7a over x minus 3. All right, so all we're doing in these problems is multiplying a negative times a negative to get a common denominator. All right, let's look at one more example before I have you do one on your own. All right, this next example, we have 4x plus 5 over x minus 3 plus 2x minus 3 over 3 minus x. Again, in the denominator, we have the same variable and the same numeral. We have an x and a 3. So in order to combine like terms, I need to have these in the correct order. Now, if I put these in the right order, I'm going to end up with negative x plus 3. All right? So what I'm going to do is I'm going to multiply everything through by a negative, which is going to change this entire numerator to being multiplied through a negative. So that negative needs to distribute to both terms. All right, so my first term stays 4x plus 5 over x minus 3. My next numerator is going to change to minus 2x plus 3 over x minus 3, because everything's been multiplied through by a negative. Since I have common denominators, I can keep my denominator, and then I'm going to combine like terms in the numerator. So I have 4x minus 2x gives me 2x, and 5 plus 3 is 8. Okay? All right, the example that I want you to do tonight is 1 over z minus 2 minus 3m over negative z plus 2. All right, go ahead and do that one tonight in your notes, and we will check it in class. Go ahead and pause the video, and when you've completed the problem, hit play for the next topic. All right, the next thing we're going to talk about is 30, 60, 90 degree triangles. All right? If we had an equilateral triangle, which means that all angles and all sides are equal, we know that all of the angles would be 60 degrees because a triangle has to have 180 degrees total. All right, so if we have 3 equal angles, we're also going to have equal sides. All right, we're going to call this 2, 2, 2. What we're going to do is we're going to use 30, 60, 90 degree triangles as similar triangles to find sides of missing triangles. All right, and we're going to do this by setting up proportions. So we're comparing one triangle to another triangle. But what we need to do is figure out what exactly the sides are equal to in our 30, 60, 90 triangle. Now, the reason it's called a 30, 60, 90 triangle is if I split my equilateral triangle straight down the middle, then this angle would still be 60. I've created a 90 degree triangle, and I've split this angle here in half, so my angle now is 30. So in my 30, 60, 90, I have a 90 degree angle, a 30 degree angle, and a 60 degree angle. Right? We still know that the hypotenuse side is 2. That remains unchanged. It's unaffected by the split. So our hypotenuse is 2. Now when I split this bottom side, I'm splitting it directly in half. So the bottom side then becomes 1. And we can use the Pythagorean theorem, a squared plus b squared plus equals c squared to solve for our missing side. Now, I'm going to go ahead and tell you what it is, that way you don't have to solve for it. But this missing side is going to be the square root of 3. All right, so we're using the Pythagorean theorem to solve for missing sides. And we're also going to use the 30, 60, 90 triangle to compare angles in other triangles. All right, so we're going to use the 30, 60 triangle to find missing sides of similar triangles. All right, remember, a similar triangle is a triangle that doesn't necessarily have the same sides length, but they all have the equal angles length. All right, so what we're going to use this 30, 60, 90 triangle. We're going to call this our reference triangle. All right, so this whole triangle here is what we would call, we're going to call this triangle our reference triangle. All right, so this is going to be our 30, 60, 90 reference triangle. We're going to use this triangle whenever we see any 30, 60, 90 degree triangle that has missing sides. We're going to use it as a reference to solve for missing sides of the triangle. So let's look at an example. In this example, I have a triangle. It's a right triangle, and it's got two missing sides. We're trying to solve for x and for y. Now, we know it's a 30, 60, 90 triangle because it has a 90 degree angle here at the bottom. A 60 degree triangle is given to you, which automatically means that this angle up here needs to be a 30 degree angle. So what we're going to do is we're going to use that information. We're going to draw a reference triangle. All right, so we're going to use our reference triangle, our 30, 60, 90. All right, so you should have written in your notes, if you have a 30, 60, 90 triangle, the base of our triangle is going to be 1, the hypotenuse is 2, and the opposite side is the square root of 3. All right, so we're going to use that as a reference triangle, and we're going to compare sides, which means we're going to have to write a proportion, and we're going to have to cross multiply and divide in order to solve. All right, so we're going to do x is to 3, or excuse me, x is to the square root of 3, as y is to 1, as 5 is to 2. All right, so there are our proportions. We're going to use this 5 over 2 to solve for our missing side. So we're going to have x over square root of 3 equals 5 halves, and we're going to have to cross multiply to find x. And we're going to have y over 1 equals 5 halves. All right, and from there you guys should know how to solve. We cross multiply and divide. So here we have 2 times x gives me 2x. 5 times the square root of 3 gives me 5 root 3. And to solve for x, we divide by 2. So x is equal to 5 root 3 over 2. Here I can cross multiply 2 times y, gives me 2y. 1 times 5 is 5. And to solve for y, we divide by 2. So y is equal to 5 halves. All right, these solutions can remain as improper fractions, that is fine. All right, what I'd like for you to do is this last example problem in your notes. Make sure that you're attempting to solve it. Make sure that you use your reference triangle and make similar sides and set of proportions in order to solve.